Net ionic equations. So again, this is another one of those topics that we have covered already, but I just wanted to do a very quick recap so that you realize that this is stuff that we still have to consider when doing things in this unit. So of course, spectator ions, these are the ions that basically don't really do anything. So you have two solutions mixing. They sometimes form precipitate, but regardless of the precipitate, there's other ions there, and they don't really participate in the reaction. So we call these ions the spectator ions. They're just spectators. They're just standing around, minding their own business, watching the reaction that's going on. So if we look at this example, okay, silver nitrate and sodium chloride. So we have our silver nitrate, our sodium chloride, and when they join together, you have the silver chloride, which is your precipitate, and your sodium nitrate. So the total ionic equation, you break these apart into their ions. So silver Ag is a 1 positive charge. A nitrate ion is a 1 negative charge. Then we have sodium, which is Na positive. You have chlorine, which is Cl negative. And the solid, the precipitate, stays as a precipitate. And then you have sodium, which is a 1 positive, and the nitrate, which is 1 negative. Of course, you don't write the ones there, but I did in this example just to show you. So then basically what happens is whatever shows up on this side and the other side, they cross each other out. They cancel each other out. So we have a nitrate here and a nitrate there. We have a sodium here and a sodium there. So this is your, now what you have left behind is your net ionic equation. So you have your silver, you have your chlorine, and then you have your silver chloride solid. So those are the ones that we take down and write into our net ionic equation. The spectator ions are the ones that we canceled out. So for example, if you have a chemical reaction between sodium sulfide and iron 2 sulfate, what I want you to do now is pause the video and identify the spectator ions and write a balanced net ionic equation. Once you have done that, turn the video back on and I will walk you through the answer. So here we go. If you look at sodium sulfide and iron 2 sulfate. So sodium sulfide, you have Na2S. Okay, you have to remember that sodium is a positive charge and there are 2 of them. So this is why it's written, and I'll just move this line out of the way, it is written as 2 Na positive. Just like, let me just move these. Sulfide is S2 negative. You have iron. It tells us in the name that it's iron 2, so we know it's Fe2 positive. And we have the sulfate ion, and that is SO4 2 negative. Sodium and sulfate on the other side, we have 2 sodium ions. We have our sulfate ion, and then of course we have our precipitate, which stays as a precipitate. So when all that is written out, you have the total ionic equation. Once you have the total ionic equation, you can start crossing out things that cancel out on each side of the equation. So you have 2 sodium here and 2 sodium there. You have the sulfate ion here and the sulfate ion there. What you have left is your sulfide, your iron, and your iron sulfide. So those, when you bring them down, make your net ionic equation. Now basically, we can identify ions based on their physical and chemical properties, and to do this we can use color tests, which is basically putting them, we can use flames. When you dissolve the ionic compound and you place that into a flame, it produces nice pretty colors. And or you can use the color of a solution and the color indicates the presence or absence of certain ions. Again, nothing really new, just a quick recap of net ionic equations.